Friends, good morning. Today we are going to discuss a very important equipment used in industry that is called compressor. And you can say it is as important as farm and turbine is. And you can say it is a workhorse of industry. So it is required to transfer a fluid, gaseous fluid from one side to other side through piping systems at high temperature and pressure. And it is must for the one industry. So we are going to discuss its classifications that but before going to discuss its classifications, I want to tell you the we are using the compressor for compress the air and process gas. But I want to give you one idea what is the cost of compressed air, how important it is when you're wasting the air, compressed air, just for anything to cleaning our cleaning the dust and others, not efficiently, then how much energy we are losing. So we are normally measuring the compressed air specification by three way. That is the system specific power, total energy consumption, and specific energy consumption. System specific power means how much kilowatt is required for producing 100 cubic feet per minute, or 1 kilowatt. How much kilowatt is required per meter cube per minute, and how it tells you how efficient the compressor is being compressed air is being produced, how efficiently you are producing the compressor. And normally for good system we can say that for producing 100 cfm, around 8 to 9 bar pressure, uh, it takes normally 19 kilowatt, 19 kilowatt. And if it is a good system, if it is a bad system, then it will take more than 90 kilowatt also per 100 cfm compressed air. Total energy means how much energy we are consuming for running the for compressed air in the compressed air over a period of time. That is equal total that is a total power required to manufacture the compressed air. And specific energy means that how much kilowatt is required per metric ton, producing per metric ton of compressed air. The three way we can define. Now we will find out the cost. How will find the cost? Rated power. Rated power we will get from the nameplate of the motor. Service factor, how much service factor, that is also written in the motor nameplates. Running hours, how much running hours is at per annum, it continuously running. Energy rate means what is the cost of the energy, and percentage of compressor loaded, how many times compressor was loaded full loaded, or how many time it is offloaded or partial loaded. And full load time, how much time it is loaded full load, how much time it is running with full load, how much time it is loading with partial load, divided by motor efficiency. That will give you the total cost of the energy. These are the parameters we have written here. Uh, Suppose like a full load, if we running with full load, then we have to load factor we have to take, load factor we have to take, running our load factor we have to take 1, like this. So if you give you some example, suppose 100 for running a compressed air, it takes you are running at HP compressor, at 200 HP compressor with rated power of 215, that operate 8,000 hours annually, and it is fully loaded at 85%, fully loaded 85% of the time, and with a motor efficiency of 95%. When it is fully loaded at that time, 85% it will loaded 85% full loaded, and the efficiency will be full loaded condition, motor efficiency will be 95%. And other time it will be loaded only 25% of the full load, and other time efficiency will be naturally loaded less power, motor efficiency will also be less 90%, and electric cost is now 0.12 dollar per kilowatt hour. It is more or less 70 multiplied by 70, it will have around 8 rupees, you can say, per kilowatt hour. So if you calculate the rated power, I have told you, previous formula I have told you rated power at this much HP, then you have to convert into kilowatt, that 0.746 0.4 second is a kilowatt. 8,000 is your running hours. 8,000 your running hour annually. 8,000. That 8,000. Rated price is $0.12 dollar per kilowatt hour. 85% it is running with full load. That's why running with full load. That's why full load means you have to consider one. And motor efficiency is 0.95 because 85% time full loaded full load, so efficiency will be motor efficiency 95. So this is this much energy, this much cost is there. And by rest of the time it is running with 0.25% load, 0.25% load. That is this one is the rated power. This is the conversion factor from HV to kilowatt. That is 8,000%, 8,000 running hours, and that 8,000 into 0.15 that will be running during at the low load. Low load means how much? Now 0.25, and cost is at the time also $0.12 per kilowatt hour divided by at the time efficiency will be 0.9. So these are the cost for producing the running a compressor for 15 that is 15% of the time total time, and 0.80 to 0.25% full load, so that will be this much. So this plus this will be the requirement. This will be the cost of the power required for running a compressor. So you can understand what is the cost involved. This is the value are in dollar. If you multiply it into 70 or 80, then you can imagine how much power cost is required to running a compressor, to make a compressed air. That's why it is very important, and efficient running of the compressor is very important. Now I will tell you the types of compression process. One is called compressor, when the pressure ratio means discharge pressure by suction pressure greater than 1.2. When a discharge pressure, if we suppose suction pressure is atmospheric and discharge pressure is 1.2, 1.2, or suction pressure is 2, then discharge pressure is more than 1.2, that is 3.5, something like that. Then this you can say it is a compression. And it can reach up to 1.2. When a pressure ratio P2 by P1, it can reach up to 10, means 1 kg suction pressure. So for single stage, it can reach up to 10 bar. When if suction pressure is 1, then discharge pressure is 10. When a single impeller, it is possible. So it is also a compressor because it is more than 1.2. So it is required for what? Now vapor extraction, refrigeration, steam power, instrument air compression, process air compression, high volume when requirement is there. At that time we are using compressor. So compressor. Then blower. When this pressure limit, discharge pressure limit is 1.11 to 1.2, from 1.11 to 1.2, we are selling it is a blower. A machine to move air at moderate pressure. This is high pressure, this is moderate pressure. And now last one is fan. It is used to move fluid or air from one point to other point when pressure range by P2 by P1 is less than up to maximum 1.11, then it is called fan. So these are the three types of machinery we are using in the industry. Industry, when discharge pressure is more than ratio, discharge pressure ratio to P2 by P1 is more than 1.2, you can say it is compressor. When it is 1.1 to 1.2, ratio is called the blower, and when it is pressure ratio up to 1.11, it is called fan. Now the types of compressor. Compressor can be two types. One is called when it runs continuously, another is intermittently. Normally continuously when it's running we call dynamic. When a displacement running intermittently, we are using displacement type compressor. Now the dynamic type compressor, it is radial and it is axial. Radial means flow will be on radial side. Axial means flow will be in the axial side. So dynamic type can be of two types, radial as well as axial. Axial normally we have seen it is in the aircraft, aeroplane and others. We are using axial type compression. Discharge pressure is less, volume is more. Here volume is more, discharge pressure is also moderately high than the axial pressure. It is called radial type compressor and continuously used. And then displacement type, it is rotor type and piston type. Rotor means rotating type and piston type. Rotating type, when it is single rotor or a double rotor, it can be single rotor or a double rotor. When it is single rotor, It can be vane type, it can be scroll type, it can be vane or scroll type, and double rotor normally screw type and roots type. I will show you the picture one by one. And then piston type, it will be single acting. You see, from one side it is suction and one this same side it is discharge. Double acting means one side suction discharge, another side also we are using piston. Both side we are using. With the piston both side we are using when it called double acting. When both side one side you are using of the piston, that is called single acting. And diaphragm means it will the diaphragm suction discharge top, and diaphragm will move uh, up and down as per the suction and discharge pressure. So this is diaphragm type. This is the piston type. All these three are piston type. And rotor type, that is a single rotor, that is vane and scroll type, or double rotor, it is screw and roots type. So the double rotor can be of two type, and one is lobe type or roots type, another one is screw type. That two screw are, you can see they are matching with each other. This is the journal bearing portion holding this single screw. That is the drive screw. This one is the runner screw. This one is the female screw. This is male. It is female. This is also resting on the bearing housing. And then this is the thrust bearing. These are the thrust bearing. This is the suction side. Suction side, as per the layout, there is a gap from this side to air can go inside the between these two screw. And when it will we will rotate it, then this flow will squeezed and coming out through the screw and going to discharge side. This is called, this is the and this one is the casing. This one is the casing. So air will go inside through the axially and then screwed. We call it initial gap will be more, then gradually when you rotate you screw, it will contact each other, or less clearance will be there. So pressurized, and then it will flow the air, drag the air from suction to the discharge side with compress. So this will give the higher pressure. And this is the shaft seal, because it cannot come to the bearing side. Also shaft seal also we are using in this side. So this is called the screw compressor. This is the lobe type compressor. This is 24 hours. It can be running. It can be running. It is oil free and oil type. Both type can be used. If you put oil, so the lubrication will be there. If you do not put oil, then you can get a pure air. So accordingly, the different type of screw compressor can be used. Here it is a lobe type. Here it is also it is called root type blower. It is a positive displacement type. Lobe type compressor that moves the large volume of gas or air at relatively low pressure by trapping the air between the two rotating counter rotating lobes. Here is the one lobe. Here is the another lobe. This is the drive lobe. This one is the idle male. This one is the female. Here running timing. This is called timing gear. Gear up, it will resting on the gear of thrust bearing, as well as the gear is there to rotate it. Because these two are rotated, and to make the clearances between the two lobes, to make the clearances adjustment, these timing gear are used. This is the type of lobes. You see, this is the dumbbell types. Air will come inside and it will be squeezed. You see, when it is rotating, this will move this way, this one move this one. So air will go from this side, this side, and drag to this side, and from here it will come to this side and drag it. You see, it will drag the air. It will drag when it is coming in, it will drag the air, compress it, and push it this side. So this is the lobe shape. This one is another lobe shape. From here, air will come to this side. Air will also come to this side, and while this is rotating this side, air will drag, and rotating this side, this air will drag from this side to send it to the outer side. And one will be drive gear, another will be male, another is female, and there is a timing gear is also there, but that will maintain the axial gap as well as not contacting each other. And through backlash you can adjust the gap and adjust the gap and so that this should not touch with each other, and minimum clearances is there. If we touching each other, then it will become very hot, and wear and tear will take place. Then this is the single vane, belt time. You see, this one is the vane type I have told you. This is the fixed scroll type. This is the scroll. This is one is the vane. This is the scroll type. Scroll means screw. You see the scroll lip types. Slip string types. This is fixed one, and this one is the orbiting scroll. When you are moving, this is even fixed, and when you are moving the rate one, the air will come inside and this will squeezed. Because the air will come inside and it will squeezed, and finally it will squeeze, and finally it will go through this, go through this. So this is called orbital type compressor. Orbital, there one will be fixed scroll, another will be orbital. It will movement will be like this through motor and through cam, and it will compress against the fixed. So air will come inside and go out. After switching, it will go outside. So this is also one type of compressor we are using. And this is the vane type. You see this shaft, eccentric shaft is there. This is the casing. This is the casing. These are the blades. When it's running, the flow will take place from here. It will squeezed and then it is going out. It is squeezed and then it is going out. This is the inlet and this is the outlet. This is also a type of compressor, quality displacement type compressor we are using in industry. So advantage and disadvantage of major type of compressor. This is a centrifugal compressor, wide range. It can be wide ranges and high reliability at and low maintenance. Reliability means there is no contact with the stationary part. That's why it is more reliable, and low maintenance and unstable at reduced flow. At reduced flow, there is a phenomena called surging that we'll discuss in detail. Stability is not there, and sensitive to gas composition. If it is denser or lighter, then accordingly the compressor will go to surge or stonewall. We'll discuss in detail. So it is so you have to run the compressor out of such area. But otherwise, it is a wide range of operation is possible, and it is very low maintenance, very high capacity. Then this is the piston type. Wide piston type is a positive displacement type. It is high efficiency because whatever taking air, whatever air or fluid you are taking, you are discharging it. So this is high efficiency and wide pressure, very high pressure range. But this is foundation should be very high because compression, this suction discharge valve is there. So a lot of energy is required where flywheel is required. So there will be heavy foundation is required. Flow pulsation will be there. One type suction, another type discharge. So there will be flow fluctuation and maintenance also very high. Maintenance also very high. Then screw type, wide range of application, lubrication or unlubricated and unlubricated both type are available, efficiency and pressure. High lubrication type have high efficiency and pressure ratio fully enclosed and compact. It is fully enclosed and compact, but it as it is screw type, so noisy and spare parts also very costly. And last one is the lobe type, simple in design because two lobes are we are normally using, limited operation range because pressure ratio is very less and capacity control limited to suction throttle only. You can do the suction throttling, nothing can be done. But here a lot of control is possible. So these are the major types of compressor. The advantage and disadvantage I have already told you. And so if you go through these slides, I think your concept about the compressor, type of compressor, etc. will be clear. When you are going to use the centrifugal compressor, what is the advantage, disadvantage, centrifugal compressor, reciprocating compressor, blower type compressor, fan, blower, difference of fan, blowers and fan and compressor are clearly defined. So if you go through the slide, your concept will be clear. I think I have, it is very simple and